Hello everyone and welcome back to my channel. It's been a while, but today I will be doing a lab in Cisco Packet Tracer, and I'll be implementing static routing and showing you how to do it. This will be a very basic lab that I will make from scratch so everyone can follow along. But here we go. So let's start off with a PTMT router. Okay, and then let's make another one. Okay, so these are two different networks. Okay, this network in the red, this red box is 193.15.0.0/24. Okay, and then the network in the green box is 194.16.0.0/24. And this is the point-to-point connection between the routers to connect the two networks together, which is 15.0.0.0/30. I'm using a /30 so we can maximize the amount of IP addresses we can use to be more resourceful with our IPv4 addresses. Okay, so anyways, let's start with these two routers. Okay, so first thing I want everyone to do is power it off, and then let's add some gigabit Ethernet interfaces, and then we can just power it back on. It's this one right here, PC router NM-1CGE. So I just power it off, and then we can add some more gigabit Ethernet interfaces. So right here, the single port Cisco gigabit Ethernet network module provides gigabit Ethernet copper connectivity for access router. So yeah, this is exactly what we need. Okay, we just need two. It's a very basic network we are doing. So the next step I want everyone to do is let's add a switch. So let's use the default 2960 switch. Okay. And then the next thing we'll do is we'll add some PCs. Okay, you can also add a laptop if you want. For this demonstration, we're going to just keep it very simple and just add computers. Okay, and then let's wire this all up. So these two devices are routers. So in this case, we'll use a copper crossover cable. So we'll connect to G0/0 and gigabit Ethernet 0/0. Okay. Next, this is a switch to a router, so this will be a copper straight through cable. Okay. Okay. And then next thing we'll do is we're going to connect the PCs together, okay, to the switches. Okay, so in this case, it's going to be a copper straight through cable again. So just do fast Ethernet, sure. Okay, and if anyone doesn't know, the reason why I'm using a crossover cable here and straight through cable here is because if it's the same device, such as a router to a router, it's a crossover cable. Now, if it's a router to a switch, it's a straight through cable. If it's a switch to a PC, straight through. Now, if it's a router to a PC, that is a crossover cable, and this is because of something called MDI and MDIX. Right, and if you want to learn more about this, I recommend just doing a quick Google search. I won't be going too into detail about that topic, but if you want to learn more about crossover and straight through, I recommend watching a video on YouTube, or a quick Google search should help you. Okay, so now that we have created our network topology, we can start configuring these devices. Okay, so would you like to enter initial configuration dialog? No, we'll just say no to that. Okay. Now, the first thing I like to usually do is I like to change the host name. So let's go into global configuration mode, right? And then let's do host name. We'll do R1, sure. And then we'll also change this name to R1. Okay, and then we'll do the same for this router as well. So let's click no. And configure terminal, and then we'll do host name R2. Okay, then we'll just change this to R2. Okay, great. So now what we want to do is we want to configure the G0/0 interface, right? So let's go into interface, Let's go into interface configuration mode. Okay, so now this is in config-if. So this is basically configuration-interface. This is interface configuration mode. So we will assign an IP address to this interface. So in this case, this is a point-to-point connection. So we'll make this. We'll use the first address for router 1. Since it's a /30 subnet, we have a total of 4 addresses, correct? 2 of the addresses are reserved for the network portion, the network address, and the broadcast address. So we have 2 available and usable IP addresses for host. So let's put the subnet mask in, which is 255.255.255.252. Okay, and then just hit enter. And then we will do no shutdown. The reason why we do that is by default, router interfaces are shut down. So we have to enable them when they are powered on, okay? So next we'll do the same for this router. So IP address 15.0.0.2 and then no shutdown. To just make it a bit simpler, so as you can see now it's green, the connection is up, so let's make it a bit simpler. So add this so you know what address we have assigned to each router and on what interface. Okay, great. Okay, so now these 2 addresses are assigned, so let's leave that alone for now. Let's assign an IP address to this subnet here. So usually I like to just assign the last usable address in a subnet. So I'll just do, since this is a /24 network, we have about 255 addresses we can use. 2 of them are reserved, of course. So in this case, we'll just use .254. Right, that'll be the last usable address, and then the address after that will be the broadcast. So let's go int g1/0. Okay. Now we will do IP address 194.16.0.254, and then let's add the subnet mask. So here we go. This is a subnet mask for a /24 network, and then this is the address we're going to be using, which will also be the default gateway for the PCs. And if anyone doesn't know what a default gateway is, it's basically if a computer wants to reach let's say a service or a server or a network that's outside of its local area network, which is what's this, then it would have to reach the default gateway. It would have to go to the default gateway and say, hey, I need to reach a DNS server. So it's going to use the default gateway, right? So we're just going to assign that. And then always remember, no shutdown, because by default, router interfaces are shut down. So we always have to enable them manually. Okay, and now let's do the same for here. So let's do, so the actual command is this, but you can also write short forms in the Cisco iOS. So, or you could also press tab. Okay, in this case, not quite working. I'm not sure why, but okay. Let's see. So IP address 193.15.0, and then we're going to assign the last usable address, so 254, and then the subnet mask. Okay, and then no shutdown. Always remember, no shutdown, or this connection will not work. Okay, so now that we have assigned our addresses, we'll also just put some notes to make it a bit easier for everyone to visually understand this. Okay, put it up top right here. Okay, great. So now we have to assign an IP address to each of these PCs. So first things first, default gateway. So as explained, if a computer wants to reach the internet or a network beyond its own network, it has to go to the default gateway, which is this IP address we assigned to this interface. So 193.15.0.254 will be the default gateway for this device, and then we'll just give this the first usable address for this network. Sure. So we'll just do O.1 subnet mask. Yep, that's fine. So /24, that'll be 255.255.255.0. Okay, and then we can also add .1. So this is just representing the host portion of the address. Okay, let's go into configuration. So let's add 193.15.0.2. Okay, so 15.0. Oh, sorry, I believe I messed up here. Sorry, .254. Sorry, I thought I was adding the host portion for a second. 193.15.0.2. Okay, so now that's assigned. Great. So now we can test connectivity. So here we can just send we can also send a ICMP echo request using the command prompt. So let's ping our default gateway, see if it works. So this is a great way to test network connectivity. And there we have it. Reply from 193.15.0.254, which is a default gateway we have configured on this interface. Great. Okay, so next thing is we have to configure this network now and its computers. So let's go to configuration. We know the network is 194.16.0.254. That's the default gateway. Okay, and then for the host address, for this computer, we'll do O.1. So the IPv4 address for this computer will be this. Subnet mask, just leave it as the default. Default gateway 194.16.0.254, and then the IPv4 address for the actual computer will be O2. Let's leave it as default, and then we can also write down some quick notes here. .2 and then .1. Okay, and now we can also test network connectivity. Do we have network connectivity to our default gateway? Now this ping is a great way to test, have you configured everything right, and if the ping does work, then you have successfully configured your default gateway and it works great. Reply from 192.16.0.254, and if it doesn't work the first time, that's because of a process called ARP. So I recommend just trying to ping the default gateway again and it should work. But if it doesn't work on the second ping, then you may have a configuration issue, which and in that case I recommend leaving a question down in the comments, or rewatching the video and making sure you have configured everything right. So now how do we get these two networks to communicate together? So what we'll do is we're going to implement static routing. Okay, so let's just exit. So to look at the routing table, as you can see here, this is the routing table of a router. And this is how a router makes its forwarding decisions on what network to go to. In this case, it does have a directly connected route to this network. Okay, so now let's implement static routing. So let's do IP route. Okay, so this is how you implement static routing to a network. 194.16.0.0. Okay, and this is the destination that we're trying to reach, and then 255.255.255.0. Okay, because we have 24 binary ones and a /24 network. And then we have to decide what is our next hop. So our next hop, if you look at this point-to-point connection between both routers, our next hop will be R2. So what's R2's IP address? It's 15.0.0.2, right? So let's write that in. And then this is basically telling R1, if you receive a packet that's destined for this network, then send it to router 2. So let's hit enter. Now watch the new routing table. As you can see, we have the code S, which means static, a static route. And it's telling R1 that if you have a packet destined for this network, send it to R2. And it has an administrative distance of 1 and a metric value of 0. So it's a very, very reliable route, or a trustworthy route, I should say. So now we have a route to R1, or we have a route to R2, right? So this PC here can reach this PC here. However, this PC can't reach this PC, so we don't have two-way communication here. So if we were to ping this PC, it's not going to work. See, failed, because there's no way for this PC to send data back to this PC. So there's no way to get a reply back. So in this case, what we're gonna do is we're gonna make a static route to this network on R2. So let's go conft, then we do IP route 15.0.0 and then to 0, and then the next best hop will be R1. Okay, so this is basically saying if you get a packet destined for this network, send it to R1. Okay, hit enter. Now you can use do show IP route. As you can see, we have a static route, administrative distance of 1, metric is 0, and it will send it to the best next hop of 15.0.0.1, which is also router 1. So now two-way communication will be established. So as you can see here, if you do this, look at this, successful. See, it works. You can also test it here. We go to desktop, command prompt, we ping 194.16.0.1. So then we're going to ping PC7 here. And there we have it. Two-way communication has been established. And that is how you implement static routing in a very basic network. And we can make this thing even more complex by adding VLANs and trunking, but we're going to do that in a later video. And I hope you found this useful and helpful, and thank you for watching.